Okay, just a minute ago I mentioned about standard position, so that's actually the definition we have here at the top. So a lot of the times you'll have instructions that will say draw the angle in standard position. So as it states here, standard position is if the initial side, so remember in the previous lesson, initial side means simply where you start. So the initial side of the angle has to be along the positive end of your x-axis, and its vertex is at the origin. So when we get ready to draw each of these examples that I have here, I have to start at the positive end of my x-axis whenever I do the measuring. So I'll always start my that rotation arrow that you saw previously. I'll have to make sure that I start at that end or in that position each time. That's, like I said, your standard position. Okay, so the first one I have 160 degrees. Alright, so I'm starting here. So of course this is positive. So since this is a positive angle, that means I have to rotate counterclockwise. So rotating from here to here is 90 degrees. Alright, so we've got to figure out, how much more we need to go. Now we've already gone 90 degrees, so that means that I need to go 70 more degrees in order to reach my total of 160. So from here to here is 90, so we're going to estimate about how much 70 degrees would be. Now coming all the way back down would be another 90. I only need to go 70. So if this is my initial side where I started, you're going to have to draw in the terminal side where you're going to stop at. So if I were to go another 70 degrees, like I said, we're just going to estimate. That would require that I come somewhere within this region, which would mean that you have 70 degrees in this portion. Of course, over here was 90 degrees. That whole quadrant was 90. And I put another 70 here, which would mean this little piece here, would have to be 20, okay? If I were you, I would go ahead, and I want you to do this in your homework. Go ahead and get in a habit as soon as you draw it, because you've got these numbers fresh on your mind. Go ahead and label how much you have in those sections, because that will benefit you when you have to go to answer some more questions later on, and you don't have to recall those numbers or refigure those numbers. It'll be right there in front of you, okay? You do have to draw the rotation arrow, because that's how you indicate which way did you go in order to get to that terminal side. So you have to indicate you went in the positive direction or you went in the negative direction. Okay, next one's 320 degrees. Okay, so again, I rotate the positive direction. So I'm starting at my positive end of my x-axis, rotating counterclockwise. So we know from here to here is 270 degrees. So you need to figure out how much more you need to go. So like I said, this is 90, this is 90, this is 90. That's 270. So to get from 270 to 320, you need to go another 50 degrees. Now, dead center would be another 45, so there's not going to be a big difference between 45 and 50 degrees, but that terminal side will come out pretty close to the middle. But your 50 degrees has to be this section, because we were at 270, and from here I went another 50 degrees. So that means this section here would have to have the 40 degrees in it. Okay, 600. Okay, all the way around one time is 360. Okay, so I know I've got to go around one time. That's 360. Okay, so if you do your 600 minus your 360, that means you have to go another 240. Okay, so let's just kind of act like we're starting back over here. I just need to continue the rotation and do another 240. Okay, so here's 90 and there's 180. Now if I only need to go 240, I don't need to come all the way back down here, because that would be another 270. So that means I've got to stop about 30 degrees short. because if I go 240, all the way here is 270. So my rotation arrow would come on here. So that means I have 60 degrees here and 30 degrees here. So that I had mentioned earlier, you can rotate multiple times, as many as you need. Okay. 2 more examples, but both of these will be angles that are negative angles. Now basically you do it the same way, we just have to rotate in a different direction. I'm still letting the positive end of my x-axis be the initial side, but this time I have to rotate clockwise. I have to come down through the 4th quadrant. Now I'm not even going to come all the way down, because coming all the way through that 4th quadrant is 90 degrees. I only need to go 75 degrees. So that would put my terminal side somewhere in this region, because from here to here would have to be this amount of 75. So of course that leaves this little section then to just have 15 degrees in it. Now when I label those sections, I'm just going to label those as being positive values, because that is the amount, that's how many degrees you have in that section. Again, the fact that it's negative is just simply telling you which way that you're going. Okay? Alright, negative 225. Okay, so again, terminal side, I've got to rotate clockwise. So here's 90 degrees, here's 180 degrees. Now I know I'm going to stop in here somewhere, because if I were to come all the way back up here, that's 270. That's too much. So I'm at 180 degrees. To get from 180 to 225, I actually need to go exactly 45 more. So this terminal side is going to end up being halfway in this 2nd quadrant. So finish your rotation arrow. So that means you have 45 degrees here, which means you also have to have 45 degrees there. Okay, next. Alright, this is the definition of a quadrantal angle. It says if the terminal side, remember terminal side's where your angle stops, so you're drawing an angle in standard position, and if you stop along one of the axes, then that angle is called a quadrantal angle. Okay, so you're still drawing in standard position, so you're still starting here. Now, there are an endless amount of quadrantal angles. I'm just going to give you 2 examples. So, for instance, one that would be positive could be that. Okay, so I rotated in the positive direction, but the catch is, remember, the terminal side lies along one of the axes. So that just means that you have to stop your rotation arrow on your x-axis or on your y-axis. So in this case, an example is 180 degrees. I could have stopped it right here. It had 90, 180, 270, 360, and you can go around as many times as you want to. A while ago, remember, I went around twice and I called this 270 degrees or 720 degrees. That is a quadrantal angle. Okay, you can even go in the negative direction. So let's say that I decide to rotate from here to here, and I stop at this end of my y-axis. Well, there's 90, 180, 270, but then it would need to be negative 270 because of the direction that I rotated. So you can just remember, there's an endless amount of correct answers, just as long as you're stopping on the x-axis or the y-axis, you have what's called a quadrantal angle.